Alright guys, let's get started. Today we are going to continue on chapter number 4 and show you guys more examples of using DC circuits analysis methods to solve AC circuits. Alright, so let's look at this circuit. In this circuit we have two sources. The first one is the voltage source on the left hand side, which has 12 0 degrees volt. So notice here this is a complex number which is presented in a polar form. And also we have a current source on the right hand side. It has 2 0 degrees amp. It is also a phasor presented in the polar form. We have two resistors. The first one is named as R1, has 1 ohms. The second one, R2, has 1 ohms either. One capacitor minus J ohms and one inductor J ohms. So just like the example we have in the last class, all components are presented in impedance and all sources are given as phasors. So we can just treat all components as resistors and treat sources as the DC source. The only special point is right now all components and the sources are presented in complex numbers. Right, so the question of this circuit is to find what's the, let me see. Yes, the question is what's the current flowing through R2, and is named as I0. So the question is, what's the value of I0? Alright, so I'm gonna show you how to solve this problem with two methods. The first method I want to mention is mesh analysis. Right. Just like the normal mesh analysis procedures, the first step we need to do is we need to define mesh currents in this circuit. We have 3 meshes or 3 blocks, so we define 3 mesh currents and name it as I1, I2, and I3. Okay. And after this step, we need to assign voltage variables on components. Let's assume the voltage on resistor is VR1. The voltage on capacitor is Vc, and the voltage on inductor is VL. The voltage on the second resistor is VR2. Polarities of those voltage variables are indicated on the diagram. Okay. Right, after these two steps, we can write KVL equations for each mesh. In the first mesh, the KVL equation is VR1 plus VL minus Vs equals to 0. Right? And for the second mesh number 2, the KVL equation is going to be Vc plus VR2 minus VL equals to 0. Okay. And for the last one, the tricky part is what's the voltage on the current source, right? And somebody may notice that the current source is connected in parallel with R2, which means the voltage on the current source is the same voltage on R2. So that's VR2. But another thing you should notice is I3 has the same current direction with IS, and there's no other current sources in the third loop, in the third mesh, which means IS equals to I3. Okay. Alright, with these 3 equations, we can solve the value of I1, I2, and I3. But before we do that, we also need to represent VR1, VR2, VC, and VL in terms of mesh currents. So for example, the first one, VR1 equals to I1 times R1, which equals to I1 times 1. And VR2 is I2 minus I3. Why is I2 minus I3? Because if I extract R2 out of the circuit, the left-hand side is I2, the right-hand side is I3. And the overall current on R2 is I0, which flows down, which is the same flowing direction with I2. So that should be I2 minus I3 equals to I0, right? Therefore, VR2 can be calculated as I2 minus I3 times R2, and that is I2 minus I3 times 1. And also VC, that equals to I2 times ZC, because on the capacitor there's only one current flowing through the capacitor. So that equals to I2 times minus J. ZC is minus J. Alright, the last one, VL, that equals to I1 minus I2 times ZL, and that is I1 minus I2 times J ohms, right? The current flowing through the inductor is similar to the situation of R2. So for this inductor, the left-hand side is I1, the right-hand side is I2, and based on our predefined voltage polarity, positive side is the top side, which means the current flows from top to bottom. That's the overall current flowing direction, right? So IL gonna be I1 minus I2, and we use IL to multiply ZL is the voltage across the inductor, and that is VL. Right, so with these four voltage variables, we can plug these four voltage variables back into the previous three equations, and then we can see the last one, this one, we can write the conclusion directly. IS equals to I3 equals to 2 amp. 0 degrees is equivalent to 2 amp, right? Because but that's the polar flow representation, and this is the rectangular flow, right? And in the same way, Vs can also be write as 12 volt, because 0 degrees is equivalent to 12 in the rectangular flow. Alright, so by solving these three equations, we can find what's the value for I1, I2, and I3. I1 equals to 26 over 5 minus 8 over 5J. Okay, unit is amp. So this is presented in the rectangular form. And I2, that equals to 18 over 5 plus 26 over 5J. Unit is also amp. Right, so after we find I1 and I2, the question is what's the value for I0? I0 can be calculated as I2 minus I3, and that equals to 18 over 5 plus 26 over 5J minus 2, and that should be 8 over 5 plus 26 over 5J. Alright, so that's the result of this question. Alright, so this is how we solve this problem by using mesh analysis. Can we also use other DC circuits analysis methods to solve this problem? The answer is yes, we can. So let me show you the second way to solve this problem. And this time I'm gonna using superposition method. But before I do that, I want to copy this question. So I don't need to redraw it. Okay. All right. And I need to get rid of those notations. Okay, and this is L, R1, C is J ohm, minus J ohms. This is R2, this is IS, okay. Alright, so the second method is we can also solve this problem by using superposition. Because in this circuit, as you can see, there are two sources. One is voltage source, the other one is current source. So in the superposition method, we can keep only one source at one time and make all other sources zero. And by repeat these steps to emulate all sources, we can get different values, and eventually we sum all results together to get the overall to get the final result, right? So let me show you how to do that. The first step we can do is we keep one source. Let's keep the voltage source and make IS the current source 0. Okay. Keep the voltage source and make the current source 0. So some people may ask how to make a current source 0. Although I repeat several times, to make a current source 0, you need to replace it with an open circuit, right? Replace with an open circuit. All right, so the new circuit is going to be look like this. Since I can copy this circuit directly, so I don't need to redraw it. Okay, and get rid of those notations. Okay, and current source is removed and being replaced with an open circuit, so there's nothing connected to these two broken points, disconnected points. Right. All right. After that, we name the current flowing through R2 as I naught dot to make a distinguish the original I naught. Right. All right. So what's the value for I naught dot? To find the value of I naught dot, as you can see, we have only a single source, which is a voltage source, and we have several components. The capacitor and the secondary resistor, very obvious, they are connected in a series way because this branch is open circuit. The current is gonna be 0, right? So we can combine C and R2 together. And since they're connected in a series way, so we can just sum them together. And name the result of the combination as Z1. Okay. Z1 equals to ZC plus R2, and that equals to 1 minus J. Right, so after this step, as you can observe, the next step we can do is these two branches, these two, this one and this one, these two branches are connected in a parallel way, right? So we can combine L and Z1 together. Since they are connected in a parallel way, we need to use the equation to find the overall impedance of these two components. And let's name the impedance after the combination as Z2. That should be ZL in parallel with Z1, and that equals to J times 1 minus J over J plus 1 minus J, which equals to J plus 1, right? Or 1 plus J. Correct. This is J ohms. Yes, that should be right. Alright, so after this step, what we can do is we can find what's the current flowing through the loop, and name it as I1. I1 should be equals to 12 divided by, let me use variables first, Vs divided by R1 plus Z2, because these two components are connected in a parallel way. So that equals to 12 divided by R1 is 1 ohms plus J plus 1 equals to 12 divided by 2 plus J. And here we have complex number divisions. We can multiply 2 minus J on both sides, right? And the bottom part becomes 2 square minus J square, and that should be 5. And top side is 24 minus 12J. Unit is amp. After you have I1, we can find I naught dot, because I1 in this circuit is the current flowing through R1, and I1 got split into two branches. One branch we can name it as IL, the other one is I naught dot, right? So I naught dot equals to, using the current division law, that is ZL divided by ZL plus Z1 times the entering current I1. Or you can also use the general equation, which is Z1 to the power of minus 1 divided by Z1 to the power of minus 1 plus ZL to the power of minus 1 times I1. And this equation is equivalent to the above one. Alright, let's plug in all values into this equation. ZL is J ohms. And Z1 is 1 minus J times 24 minus 12J divided by 5. That's the value of I1, right? And that should be equals to 24J plus 12 divided by 5. Unit is amp. Okay. All right, so after we have the first result, which is the value of I naught when Vs, the voltage source, is presented. The second step is we keep the other source, which is the current source. Keep the current source Is and make Vs 0, right? And by to make a voltage source 0, you need to replace it with a short circuit. Okay. Alright, so let me copy this diagram first. Okay, copy. And this time we're gonna remove the other source, which is the voltage source. So let's get rid of the voltage source and replace the voltage source with a short circuit, which means we need to connect these two separate points with a short circuit, with a jump cable. Alright, and let's name this time I naught as I naught double dot. But there's a tricky part. There's a tricky point for this circuit. As you can see, if the current flows from the positive side of this current source, and when it flows through R2, this current has the opposite flowing direction with I naught double dot, right? In other words, to make this circuit, to make these analyzed procedures easily, we can flip the direction of current source IS, and let's make it flowing up. Let's make it pointing up. And by doing that, you need to add a negative sign in front of the current source output value, right? And now, as you can see, the current flowing from the positive side of the current source, and it flows through R2, and this current has the same flowing direction with I naught double dot, right? So now we don't need to worry about the polarity things because they are flowing in the same direction. All right, so let's find what's the value for I naught double dot. R1 and L, these two components are connected in parallel, which means we can combine these two components together at the first place. Let's name the impedance after the combination as Z3, okay? And the rest of the circuit looks like this. The current source value right now is minus 2 amp. This is IS, okay? This is R2, 1 ohms, and this is I naught double dot. This is J. This is capacitor C. Alright, Z3, that should be equals to R1 plus ZL, which equals to 1 plus J ohms. I'm sorry, that's a mistake. Because they're connected in parallel, right? So we need to use the equation to find what's the value for Z3. That should be R1 times ZL divided by R1 plus ZL. And that equals to 1 times J divided by 1 plus J. And then Z3 and capacitor C are connected in series, which means these two components can be summed together to find the overall impedance. And let's name the new impedance as Z4, okay? This is R2. This is IS minus 2 amp. Alright, so as you can see, this circuit is a very simple current division law circuit, right? We have an entering current IS, and IS got split into two branches. One branch is IZ4, which is the current flowing through Z4. The other branch is I naught double dot, which is the current flowing through R2. And I naught double dot is also the result we are looking for. So let's find Z4 first. Z4 should be Z3 plus ZC, and that equals to 1 times J over 1 plus J, plus ZC is minus J ohms, and that equals to J times 1 minus J divided by 2 minus J, right? That is J plus 1 over 2 minus 2J over 2, which equals to 1 minus J, right? The unit is ohms. Right, after we find Z4, we can find I naught double dot by using the current division law, and that should be Z4 divided by Z4 plus R2 times the current source value IS, and that is 1 minus j over 2 divided by 1 minus j over 2 plus R2 is 1 ohms times current source value minus 2 amp, which equals to do this calculation, we can multiply 2 on both sides of this fraction number. And that should be 1 minus j divided by 1 minus j plus 2 times minus 2, which equals to 1 minus j, 3 minus j times minus 2. Okay. And after, at this step, let's continue. So we can do the complex conjugate. We can multiply complex conjugate on both sides. And the bottom part becomes 9 plus 1 times minus 2, which equals to 3 plus j minus 3j plus 1. Let me check. There's 3 plus j minus 3j minus j squared. J squared is minus 1, and minus minus becomes positive, right? Divided by 10 times minus 2, which equals to 4 minus 2j divided by 5. Don't forget the minus sign here. So the final result is going to be 2j minus 4 divided by 5. Unit is also amp. Alright, so after we have I naught double dot, the last step is we just need to sum the two previous results together. Sum, then up, right? This then means I naught dot and I naught double dot, right? So let's do that. I naught, the final result should be I naught dot plus I naught double dot, which equals to I naught dot as we calculated previously, that is 24, let me see, 24j plus 12 divided by 5. I naught double dot is 2j minus 4 divided by 5. So by summing them together, we have 8 plus 26j divided by 5. Okay, and this result, don't forget, the unit of this result is amp, and this result should be very similar to the previous one. Should be identical with the previous one, right? And you can check it is exactly the same value we have previously. All right, so that's how we use these two methods to solve this problem. The first one is the mesh analysis, and the second one is superposition. And in today's class, I'm also gonna show you the third step. Okay, the third method, method number 3. We can also use source transformation to solve this problem. Source transformation, but instead of using this circuit, because we are pretty familiar with this circuit, let me use the circuit, a new circuit in your homework question. Okay. By the way, the homework is that should be homework number 4. Homework number 4 is posted on the Canvas, and the due date is next Wednesday. Today is March 20th, and the due date for this homework is March 25, before 3 p.m. Before 3 p.m. March 25, 3 p.m. Okay. All right, let me find the let me look at the circuit that we have in the homework. And we can use the source transformation to solve that problem. All right, final one. Okay, let's look at this circuit. Okay, so in this circuit we have a single voltage source Vs, a current source Is. Vs is 60 degrees volt, Is is 20 degrees amp. We have one resistor, R1, 2 ohms, one inductor, 1 j ohms, and second resistor, 1 ohms. And the question is, what's the voltage across the first resistor, name it as V naught. Okay, so we want to find what's the value for V naught. Alright, so to solve this problem, by using source transformation, what we can do is we can convert these combinations, the current source and a resistor in parallel, into a voltage source and a resistor in series. In case you forget what is the source transformation, let me quickly review the source transformation theory. So in the source transformation, it says if you have a current source and a resistor connected in parallel, then you can convert this configuration into a voltage source, Vs, and a resistor in series. Okay, and this is a bidirectional transformation. So Vs equals to Is times Ri, and Rv equals to Ri. You can also convert from the right hand side to the left hand side, and Is gonna be Vs divided by Rv, and Ri equals to Rv. Okay. Alright, so in this circuit, we're gonna use the transformation from left hand side to the right hand side, right? Alright, so let me copy this circuit. Therefore, I don't need to redraw this circuit. Okay, copy. The right hand side, since we convert that to a voltage source and a resistor in series, so we can get rid of the current source. Or after the transformation, the rest of the circuit looks like this. This is still R2, and after transformation, this Vs, let's call it Vs2, should be Is times R2, which equals to 2 times 1 is 2 volt. Okay. Right, so in this circuit, the next step we can do is we can combine R1 and L together because they are connected in parallel, which means the voltage on R1 is also the voltage on the inductor L, right? And R1 and L, they are connected in a parallel way. So let's name the impedance after the combination as Z0, Z1. The voltage on Z1 should also be V0, right? Because in the original circuit, R1 and L, they are connected in parallel. Right, so this is still Vs, this is R2, this is Vs2. Okay, Vs2 is 2 volt. Alright, the rest of work should be easy, right? Because you can define, we can use KVL, right? We can use KVL to find mesh current. But this mesh current, you need to be very careful because the current direction should be flow this way. The overall current should flow this way, because based on the polarity of V0, right? So, which means the mesh current flows anti-clockwise direction. So let's name it as I1. And following the polarity of I1, following the direction of I1, the voltage on R2 should be positive on the right hand side, negative on the left hand side. Right, so let's write KVL equation of this circuit. That should be positive VR2, positive VS, positive V naught, and minus VS2 equals to 0. V2 can be written as I1 times R2, Vs is 6, V naught is I1 times Z1, right? And Z1 is the combination of R1 and L, and they're connected in a parallel way. So Z1 equals to 2 times J divided by 2 plus J, right? And then plus minus 2 equals to 0, okay? And let's plug in all the values into this equation. That should be I1 times R2 is, what's the value for R2? Is 1 ohms. I1 times 1 plus 4 plus I1 times 2J, 2 plus J equals to 0. So now we have a single unknown variable, which is I1. And that should be I1 times 2J plus 2 plus J divided by 2 plus J equals to minus 4. And that should be I1 times 2 plus 3J times 2 minus J divided by 5 equals to minus 4. And that should be I1 times 4 minus 2J plus 6J, right? And plus 3 divided by 5, which equals to minus 4. All right, and we are very close to the final answer. That equals to I1 times 7 plus 4J equals to minus 20. And I1 is minus 20 divided by 7 plus 4J. All right, so after we have I1, the rest of work should be easy, because V naught, which is the voltage across Z1, equals to I1 times Z1, which equals to minus 20 over 7 plus 2J times 2J over 2 plus J. Okay. And we can solve this problem. We can find the result of this calculation. That should be 7 plus 4J times 2 plus J divide on the top side is minus 40J, right? All right, so that's how we solve this problem by using source transformation. So in general, after a circuit is given with impedance and phasors, this AC circuit is identical. It cannot be identical rigorously, but in logic, this circuit is equivalent to a DC circuit. In other words, all DC circuits analysis methods, such as in this lecture, we introduce mesh analysis, superposition method, and source transformation. All those AC sources, all those DC sources analysis methods are feasible to solve these AC circuits. Okay. All right. So at the end of this class, I want to remind you guys that we have a homework due on. Next Wednesday, and on Friday, which is after today's class, I will post a quiz, and it has 2 questions. Okay, so finish these 2 quiz in the weekends, and on Monday, submit your work on the Canvas. Okay. All right, so let's end up here and have a wonderful weekend.